good morning. How are you, everybody? We're going to do a little bit of a chemistry lesson today. So, I want to explain to you about something called redox, which is reduction oxidation. Well, for us to know that, for us to understand that, we need to kind of go through some things that are basic. So come on over, let me explain to you. So, if you look at an atom, any atomic structure has a nucleus and an electron. In the nucleus, there's usually protons and neutrons. And then the electron is over here in the space outside. Now, this can take many shapes and so on and so forth, and I'm not going to go into too much detail with it. And also some atoms have too many layers of electrons. Things that you need to understand is that every layer can take so many electrons. So in the first layer you can take 2 and so on and so forth, in the second layer and in the third layer and so on and so forth. Anyway, I'm not going to go through all that, but what I want to do is I want to show you that in each of these layers the electrons are actually paired up, somehow. So there are 2 to every one of them. So let's go for a hydrogen atom. A hydrogen atom is 1 and 1, which means it has 1 electron, 1 proton. Well, basically what it means is that it's got only 1 electron in this little area. So just think of it as an apartment with just 1 person. Okay, that 1 person needs a buddy, so it needs another electron from somewhere. So this hydrogen atom is on its own, cannot live on its own. It becomes very agitated. It wants somebody there, so it wants another hydrogen atom, and then they can share these 2, and then the 2 will live together very happily. So this is the hydrogen atom, and then this is another hydrogen atom, and then the 2 then will be sharing the 2 electrons, and they'll be happy, and that would be H2, which is the hydrogen gas. Now, given that, what I'm trying to explain to you is that this hydrogen electron can be swinging over here to the other one, and as it's doing that, this has no hydrogen electron at all. So it becomes an H positive unit, whereas this one here becomes an H negative unit because it has more electrons in it. Well, if we think about different combinations, so let's say HCl. Let's go through a different paper for that. So hydrogen and chloride, right? So hydrogen has 1 atom. This one here on the outer layer, it has 1 that's missing 1, but it has many more inside that 1 layer. So it wants 1, this one has 1, so this one gives it 1, this one takes it, and it's happy, and then we have HCl. Or let's say sodium. Sodium is the same way. It has 1 electron at the end here, and it can give it away, and Cl here needs 1 in its space, and they share it together, and we have an ACl, which is regular table salt. That's what table salt is. So this movement of electron from one entity to the next is the redox that everybody talks about, the oxidation reduction. Okay, so this atom, that's the chlorine atom, when it doesn't have an electron, it is in a state whereby it's agitated. It needs an electron, so it's looking for an electron to satisfy its outermost layer. So when it is agitated, it is on a high level of excitement. It wants the electron. The sodium has an electron to give, okay? When this electron goes over here, then this chlorine atom is satisfied. So its energy is just reduced. It's kind of calmed down. So this is reduced, right? When it is reduced, it is calming down. Now this becomes oxidized, okay? So because now this one needs an electron back because we just took its electron away. Now it doesn't take one electron, it takes two of them, right? So that's why these here then share in the outer layer of this one versus the outer layer of this one. And that's the oxidation reaction, okay?
Go.
So if you think about it, this now becomes a reduction agent because it's actually going to reduce whatever it comes in contact with. And this becomes an oxidizing agent because it's going to oxidize whatever it can come in contact with. As these electrons are moving around in those two atomic structures, it's going to make one at one time negative, one at one time negative, one is positive, one is positive simultaneously. So this one here would be negative, this would be positive, and then positive and negative depends on where the electrons are at that moment, you know. So that's what this oxidation reaction, redox reaction is all about. Now this happens, the NCl is salt, HCl is hydrochloric acid. So what I'm trying to explain to you is we have this in our stomach, we eat this stuff. So this happens in real life. As we are living, we are doing these things. And that's only two examples. Now, breathing is another one. Chlorophyll is another one that works like that. There's many, many, many redox reactions in our body. So I hope I explained it enough. Okay? If you have any questions, by all means, you know, let me know. I'll be more than happy to explain certain things because sometimes those things are very hard and obtuse and they're kind of hard to understand and be very well in your mind, you know.